So this is a video on translating graphs. So let's see. So when you look at the information, what we're going to do is look at position versus time. You have to know that a position versus time graph, position means it's a measurement of distance or displacement in meters. Time is in seconds. So if you find the slope, that means you're going to have the meters divided by the seconds, and that's going to give you the velocity of the object. So that's what slope's going to mean for position over time. And what we're going to do is we're going to compare the slope of a position versus time and use the slope to plug it in right next door to a velocity over time. So what we're going to do is we're going to look at graph 1 and 2 as position versus time, and then we'll see how it looks over at 1 and 2 on velocity versus time. All right, the first slope, it says that it's a low slope, so we have a slow velocity. So when we look at number 1 on position, it's very low. Number 2 is very steep. Very steep means it's going faster, so it has a high slope. And so the terms low slope and high slope, I don't mind those here, but let's look at the picture in the middle over here. This is the velocity versus time graph, and they say slow velocity. Okay, slow velocity simply means that our velocity here is about 1. We'll list that at 1. And we'll use the high one at something like 4. Okay, 4 is faster than 1. Notice that for these, I don't like this term low slope equals low speed. That refers back to this part of number 1 on a position versus time. Over here on the right, it gives the wrong impression that this is a low slope. This is actually a zero slope because we have zero acceleration. When you look at a position over time, a straight line means that our speed is a constant, steady rate. A constant, steady rate means we have no acceleration. So all of these things, these first 3 are going to have a zero acceleration because the slope of a velocity over time graph tells us the acceleration of the object. So this is zero acceleration because on the position versus time graph, it is a straight line. Okay, so positive slope, there is no positive slope here. They're referring back to the previous position versus time graph. So the idea is that very low angle on the position versus time ends up with just like a 1 for our speed. This is our 1 for our velocity all the way across. And that really steep one gives us more like a 4. So the steeper the position versus time, the higher up the y-axis that we go for our velocity. Whatever the slope is for this would be shown as the velocity of the object over here in a straight line, zero slope, no acceleration. All right, graphs 3 and 4. Graphs 3 and 4. Let's look at the position versus time graph. All right, an object at rest. An object at rest, its position does not change. So the slope is 0. So we have 0 velocity because we have a 0 slope. The negative velocity means that we're going backwards, or we're going left, or we're going from something like 100 meters and coming toward the 0 mark. So that means someone's coming at us. That means they're going a negative velocity. So a negative velocity means it's going down left to right. Horizontal means it's 0 velocity. They're not moving. The position is the same. Let's say it's 1. So it's 1, 1, 1, 1, 1. It's not moving, so it's not going anywhere. So a 0 velocity. Let's see what 0 velocity looks like on a velocity versus time graph. It's a 0 velocity just right along the 0 line. Nothing happening here. Now, the negative velocity, because it's a straight line, we find the slope, and the slope will give us our negative velocity. So it's a constant velocity. So once we find our slope, we'll show it over here. Let's say that this is a -2. It's -2, -2, -2, because this is a constant 0 acceleration. There's no change. It's a constant velocity, okay, and it's negative. And so it's going to be a straight line down here, the same velocity over and over and over again, 0 acceleration. So all four of these first graphs have zero acceleration. They're all constant at one thing, one speed or at zero speed. So zero acceleration. So on the velocity versus time graph, they're all zero slope. Even though only one of them is at the actual zero velocity, they're all zero acceleration. Alrighty, so now let's go to number 5 and number 6. Okay, now on this one, a curve means we have acceleration. A curve on a position versus time graph means we have acceleration. That means our speed is not constant. It's changing in some way, shape, or form. So if it curves up and to the left, I'm going to call that to the left, it's speeding up. If it curves down or to the right, it's got a negative acceleration. So we'll see what this looks like, because here it looks like they're both just curving to the right. But I'll show you what it looks like whenever we put it in the middle of a graph that's happening. So positive acceleration will look like this. It will look like a straight line going up left to right. So this is positive acceleration. And the slope of this line would represent the slope of this curve. We can't do the slope of a curve with our math, but when we see this curve and we find the velocity at all these different places, we can then plug it in over here and get a straight line to find our acceleration. Same thing happens with the negative. This is a negative curve. We would see that our position is getting left, so this is going to be a negative, just like this one up here is a negative velocity. This is a change in the negative velocity, so it's a negative acceleration because of the curve. So we're going to see that as a straight line. The acceleration is constant in the negative over here. Negative acceleration, positive acceleration. We don't know numbers yet. All right, so those are the things you're going to be doing on the back. So let's look at the back, and we will see how we can put it together. We're not going to worry about the acceleration versus time stuff. All right, so we're not going to worry about acceleration versus time. All right, you read this graph, and we say at position A, our position is unchanging. So for position A, 1, 2, 3 lines, we are at zero velocity. So that's what that whole reading thing is about. All right, at position C, we are also at zero velocity because it is horizontal through here. So 1, 2, I'm going to skip 1, 2, and I'm going to go back to 0 for 1, 2, 3. So 1, 2, 3. So I'm back to 0 here. Now, B and D, what are we going to do with them? Well, B has to be a negative velocity because the slope is negative because it's going down left to right. So we're going 1, 2 across, and we're going 1, 2 down. 2 divided by 2, but our change in y is a negative 2, so we have a negative 1. This is the negative 1 line, 1 below the 0, so that means we drop down here to the negative 1. Then we go back up to the 0 right here. So slope here is 0, slope here is 0, and then slope here for B is negative 1. So we translate that into this. At A, our slope is 0. At B, our slope is negative 1. And at C, our slope is 0. Then at D, we go 1, 2, 3, 4 up, and we go over 1, 2. 4 over 2 is 2. So we want to come up here to the positive 2. And this is where we're going to be for the last two. Looking at the grids here, we've got 1, 2 grid. So A is 0, B is negative 1, D is 2, positive 2. So it's going to correspond over here on our right to A is at 0, B is at negative 1, C is at 0, and then D is at positive 2. So that's how you're going to translate the position versus time to the velocity versus time. Alrighty. All right, so let's look at this. Your paper had the line up here. So let's do that. We'll scratch this out. This is the 0. So this is a 1, 2. You're at the 3. So for the first 1, 2, 3 grids, we want to have a slope of 3 over here. So we're going to start as low as we can. We're going to go up 1, 2, 3, and come over 1. 1, 2, 3, and over 1. 1, 2, off the grid and over 1. So what we're going to have here is as straight a line as possible right through these parts. And that's going to correspond to a +3 slope. Okay? To correspond with our 3 over here with our velocity. Now we immediately are going to drop down to a -1. So that doesn't mean this right here is not a slope. That does not exist. This is the time stamp. So at the 3-second mark, if that's what we had here, we would immediately drop to a -1. So -1 for 1, 2, 3 spots means I'm going to come over 1 and down, over 1 and down, over 1 and down. That means for 3 grids, I'm going -1. 1, 2, 3 grids at -1. So this is a -1 slope to correspond with this part right here. Now at C, my velocity is 0. That means my position will not change. So this is C. So this is B. This is A. So see how that works? So the idea is you're taking a velocity versus time, telling me it's 3 meters per second for the velocity. So you got to give me a slope of +3. That means 3 up and 1 over to the right for 3 seconds. And then you're going to come back down for -1 for 3 seconds. So 1, 2, 3. And then you're going to be steady. 0 slope, which means we have no change in position. All right. Here at B, we're going to have a curve. So we're not going to play with it for a while. Let me draw a graph over here. This is velocity versus time. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I need 10 lines coming across. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, this is my 0 mark. All right, so I look at this slope, and my drawing isn't as precise as yours, but I think it was 1, 2, 3, 4, 5 up, and 1, 2, 3, 4 over. So 5 divided by 4 gives you 1.25. So over here you've got the 1, 2, 3. So 1.25 would be about right here. We're going to label that 1.25. And we've got 4 dots. So 1, 2, 3, 4 at the 1.25. Okay, so that's the A. We're going to skip the B. The B goes from here to here, so that's 1, 2. And then at C, this is a straight line, so this is a 0 slope. So we want to go 1, 2, and then come down here to 0 slope. Now that means we don't have to worry about what B is doing. We're just going to take where A ends. This is the B category, and here's the C. We're just going to connect as straight a line as possible from the 1.25 to the 0. So this is a negative slope, so it's a negative acceleration. This curve is to the right, and that's a negative acceleration, so we have exactly what we're looking for. All right, same thing, only opposite. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is my 0. All right, how fast am I going at A? Position isn't changing, so I have 1, 2, 3, 4. I am going 0 for 4 spots. This is A. Then I'm going to have this change right here at B for 1, 2, 3 spaces. So 1, 2, 3 spaces. And what I'm going to do is now I'm going to go find C. C is this area right here. So we go up 1, 2, 3, 4, 5. 5 over 1, 2, 3. 5 over 3. 1.67. So this is 1 and this is 2. What I want to be is 1.67 right there. So from this line to that line, it's 1.67. So how much did I accelerate? What will my slope look like? Well, I can't get the slope during this curved portion, but what I can do is I can connect where I was going 0 to where I'm going 1.67 with as straight a line as possible. And that will give me my slope. So this is B, and this is C. C, the slope is 1.67, so I have it over here at 1.67. It's my velocity over time. That's how you translate graphs. Good luck, guys. The problem